Welcome to Honors Physics Podcast. This is question number 9 from chapter 16. We have a transverse wave on a string, which is going up and down and up and down and up and down. Its wavelength is 0.18 meters. The amplitude is 2 millimeters, and we're looking for how much time is required for it to move a total distance of 1 kilometer. Now we have to be a little careful. We are on a string, and this string is vibrating up and down. So this particular particle right here does not leave this plane, this vertical plane, as seen by the dashed line. What it does do, though, is it goes from here to the middle at our equilibrium position, down to the bottom in our trough, back up to the equilibrium position, and then back up to the top here. Each time it does that, it travels a distance of 2 millimeters. So that means that in one period, our particle moves 8 millimeters vertically. Okay, it moves 8 millimeters vertically. So if we're trying to find how long it will take to go through 1 kilometer, we need to know two things. We need to know how many millimeters it moves every period, and now we need to figure out how many periods it's going to move through. And then after that, we need to know the time that it will take for each period, and we can figure out how long it's going to take. So if we're moving through 1 kilometer, that's 1,000 meters, and we're going to divide that by 8 millimeters per period, keeping in mind that millimeters are 10 to the negative third, we end up with 125,000 periods, right? Because we're going to cancel our millimeters with our meters, and the periods in the bottom of the bottom will come up to the top. So it's going to take 125,000 periods to travel 1 kilometer total. So now we just need to figure out how long each period is, because if we can figure out the length of time per one period, then our units of period will cancel out, and we can come up with the final answer. So to find our period, or time per period, that's just finding capital T. Capital T is 1 over our frequency, and because V is equal to our lambda times our frequency, we can figure this out. Our velocity, as seen up here, is 450 meters per second, and that's going to equal our wavelength, which is 0.18 times our frequency. So when you do that, you end up with a frequency equal to 2,500. So that means our period is 1 over 2,500. And so we can then take our total time, T total, is equal to 125,000 times 1 over 2,500, right? Because this is the amount of time it takes per one period. So we end up with 50 seconds. 50 seconds. Now you may think that that is a terribly large distance to go through in 50 seconds, but the thing to keep in mind is that our frequency is 2,500 hertz. Which means it's going up and down 2,500 times every 1 second. That is a very, very large frequency. And that is question number 9 from Honors Physics Chapter 1, or Chapter 16, Question 1. Homework 1.